Srikant Tadwarti. You watching Srikant Ideal Chemistry. In this video, we are discussing about applications of mesomeric effect or resonance effect. In that, first we discussing about stability of carbocations and carbon free radicals or free radicals. Here, the stability of carbocation and free radicals are directly proportional to plus M effect or plus I effect, and inversely proportional to minus M effect. So here stability of carbocation and carbon free radical is directly proportional to plus M effect, and inversely proportional to minus M effect. At the same time, it is directly proportional to extent of resonance. Okay, now I just give some examples based on the plus M effect, minus M effect, and resonance effect. So here we are discussing about some examples based on the stability of carbocation and carbon free radical. So you know very well, stability of carbocation and carbon free radical directly proportional to plus M effect, inversely proportional to minus M effect. At the same time, it is directly proportional to plus I effect and inversely proportional to minus I effect also. We already discussed it inductor effect. So this is first example. Here if you see this, this is a secondary carbocation, and here if you see this, it is primary carbocation, but here we have conjugation. So these pi electrons can be shifting to here. So here conjugation is present. So if you see this, here it is secondary carbocation, here we have the conjugation, and here we have one plus I group. So plus I group always increase the stability of carbocation. So here we have two plus I groups. This is one methyl group and this is one methyl group. And when you go for the the positive charge can conjugate along the ring. So here resonance is present. Resonance. When you see this, it is tertiary carbocation. Here three plus I groups are present. So based on this, if you take the order of their stability, high priority for extent of resonance. So here resonance is there and here is there here, but here resonance shows in the benzene ring. So here we got more number of resonating structures. So here extent of resonance means more number of resonating structures. So compound 4 can show the maximum stability. After fourth one, when you see in the second structure and third structure we have conjugation, but in the third structure we have conjugation and plus I group is there. Plus I group can increase the stability of carbocation. So next position is third structure. After second one, then when you compare the first and fifth structure, fifth one is tertiary carbocation and first one is secondary carbocation. Tertiary carbocation more stable than secondary carbocation. So next position is fifth, and first structure is at last. So this is the order of stability of given given compounds. Okay, next we go for the example 2. So in the example 2, here we have four structures. First one is benzyl carbocation. Here we have conjugation. Here it shows the resonance. In the first structure we get the resonance with the 3 pi bonds. Here we get conjugation with the 2 pi bonds. Conjugation with the 2 pi bonds. Here no conjugation is present. So here it is just primary carbocation, and here here also show the conjugation but with 1 pi bond. So number of pi bonds participate in the conjugation increase, stability also increase. So if you take the order of stability of carbocation, so in the first structure shows the maximum stability due to resonance. After second structure, 2 pi bonds involved in the conjugation with the positive charge. After fourth structure, why? Because 1 pi bond present in the conjugation, and at last is third one due to absence of conjugation. So this is the order of stability of given 4 structures. And next example, so example 3. So in the example 3, here we have the 5 structures. So we need to arrange these 5 structures based on their order of stability. So first structure is just a carbocation, secondary carbocation. In the second structure, if you see this, the lone pair electrons present on the oxygen can be participate in the conjugation. Here conjugation exists between lone pair and positive charge. So conjugation is involved. If conjugation is involved, that is more stable. If you take the order of stability. Okay, so after up to now second structure is more stable due to conjugation. After when you see the third structure, in the third structure we have one carbon between nitrogen and positive charge. Here NH acting as a electronegative atom or minus I group. Here also oxygen minus I group. Here also nitrogen acting as a minus I group. If the minus I group decrease the stability of carbocation or destabilize the stability of carbocation. So if the distance between the positive charge and minus I group, stability is increase. In that fifth structure is more stable than third and fourth structure. So due to presence of minus I groups in third, fourth, fifth structure, those are less stable when compared to the first one. And second one is more stable compared to the first one due to conjugation. After in third, fourth and fifth structure, in the fifth structure, the distance between minus I group and positive charge is very high, so it is more stable than third and fourth structure. So if you arrange, highest position is second structure, after second first one, after first fifth one. Okay, then we need to compare third one, fourth one. In the third and fourth one, oxygen having more electronegativity when compared to the nitrogen. So if more electricity is present, it can be destabilize the carbocation. So third structure is more stable than fourth one. So next position is third and last position is fourth due to high electronegativity of oxygen. So this is the order. And next example. So when you go for example 4, here we have the four structures. In the first structure, NO2 group at ortho position. In the second structure, present at meta position. In third structure, present at para position of benzyl carbocation. Fourth one is benzyl carbocation is given. So we need to arrange these four structures based on their order of stability. So NO2 minus M group. Okay, here you know very well mesomeric effect always operated ortho position and para position. So here NO2 present at meta position. So here only minus M effect can be possible. Here minus M, here minus I, here minus M, and this is reference structure. If we take the order of stability, the minus M power can be destabilize the minus powers. I mean minus I power, minus M power. Both are destabilize the carbocation. So reference structure is more stable when compared to the remaining one due to absence of minus I groups. After here meta structure is more stable. Why? Because mesomeric effect is more effective than inductive effect. That's why second structure is more stable. After when you compare the first and third structure, minus effect, any minus effect can shows more in a para position. So then third one after first one. So this is the order of stability. So any substance, any carbocation or carbanion is stable in para position when compared to the ortho position. So based on that, third structure is more stable than first structure. So this is the order of stability. 4, 2, 3, 1. Next friends, this is next example. So in this example, the methyl group present at ortho position of benzyl carbocation. In the second structure we have at meta position. In third structure we have at para position, and fourth one is benzyl carbocation. So when you arrange the numbering these two compounds 1, 2, 3, 4. So we need to arrange based on their order of stability. So if you see this, the methyl group present at ortho position, here plus I effect can be operated. At meta position plus I effect operated. Here also plus I effect can be operated, and it is reference structure, and here it is taken as plus M. Why? Because it is electron releasing group, so it is acting as a plus M group. So this is effect. So the plus M group or plus I group can be increase the stability of carbocation, but particularly the stability of carbocation when you observe that plus M effect always shows more effect at ortho position. So first structure is more stable than third structure. Why? Because in the first and third structure both plus I effect and plus M effect can be operated. In the second structure at a meta position only plus I effect can be operated. So when you arrange those compound, so first structure is more stable, after third structure, after second, at last is a fourth structure. So this is the order of stability of given four compounds. Okay, this is next example. Here we take the methoxy group in presence of methyl group. Here methoxy group shows both plus M effect. Here at second structure it shows the minus I effect. Why? Because at meta position mesomeric effect can operates. At ortho para position also it can show the plus M effect, and it is reference structure. If we take the order of their stability, so here you know very well ortho position is more effective than para position for plus M effect. So first structure is more stable. After third structure, after in the second structure methoxy group shows the minus I effect. So reference structure is more stable and second structure is at last. So this is the order of their stability. So this is next example. So in this example we just take the chlorine. So chlorine also can shows the both plus I and plus M effect. So at ortho position it shows the plus M and minus I. Here plus minus I effect. Here plus M and minus I effect. Here it is a reference structure. So if we take the order of stability, so halogens are quite opposite in the when compared to the plus M effect and minus IM effect. So those are shows the more effect in a para position. So third structure is more stable than first structure after fourth structure, and second structure is at last due to showing off only minus I effect. So minus I effect is destabilizes. So second structure we get at last position. Okay. And next one is example 8. So here we have more compounds. So listen carefully. All these compounds we need to arrange based on order of their stability. Here NO2 all are present at para position. NO2 shows minus M effect. CHO shows minus M effect. NH2 plus M effect. OH plus M effect. CH3 plus I effect. Fluorine plus M effect. Chlorine plus M effect. This is reference. So hydrogen is present. Methoxy, it is also shows the plus M effect. So plus M effect stabilize the carbocation, minus M effect destabilize the carbocation. So before going to order, so here first we take the order of plus M power and minus M power. So if you take the plus M power order, so here in the plus M power NH2 shows maximum plus M power. Sorry, one second. So NH2 shows the maximum plus M power. If you take the plus M power, NH2 is maximum plus M power. So after methoxy shows the maximum plus M power. After OH, after fluorine, after chlorine, then reference. So this is the order of plus M power. If you take the order of minus M power, here shows the minus M power by the only two groups. So NO2 is more minus M power than aldehyde group. Okay. So based on this we can write the order of their stability. So highest position is for third structure NH2, after methoxy ninth structure, after alcohol fourth structure, after fluorine sixth structure, after chlorine seventh structure, after methyl fifth structure, after reference structure eighth one, after second structure more minus I power least stable. So first structure is at last. So this is the order of stability of given 9 structures. Okay. So this is about the stability of carbocation, and I just give one example for stability of carbon free radical. So here we have 3 free radicals, structure 1, structure 2 and structure 3. Here each one here star mark is representation of odd electron or free electron. So these free electron can be transmitted along benzene ring. So here it can shows the 4 resonating structures. Here we get 7 resonating structures. Sorry. Here we get 10 resonating structures. Here we get the 7 resonating structure. The stability of free radical is directly proportional to extent of resonance. I mean number of resonating structures. Based on this third structure, second structure shows maximum resonating structures 10. After third one, and at last first one. So this is the order of stability of given free radicals. Okay students, this is about stability of carbon free radicals or carbocations. In the next video we are discussing about acidic nature, acidic strength of carboxylic next video we are discussing stability of carbanions. if you like, okay students, if you like my teaching, please subscribe to my channel. Please like and share my videos. Thank you.